something called as a truss design. This is the basis of most of the bridges which were made in the 18th and the 19th century, and it calls for basic knowledge of physics and point forces and basic math, and this small design could lead to yeah. The challenge is to build a bridge that spans 30 inches and holds the most weight, and all you need is straws and sewing pins and some scotch tape. And some of these bridges were made based on the concepts you got from designing a small truss, and all it required was some little physics, little math, and little ingenuity from the engineer. So that's one part of civil engineering, which is structures. Now we go into something called as concrete design. Concrete is a mix of something called as Portland cement, water, soft and hard aggregates, and some chemical admixtures, and these give this lend strength to the mixture, and it becomes something called as concrete, which is used as a structural component. These pictures show the procedure to make concrete. It's basically adding water to cement, Portland cement, and then letting it solidify, and then you get it in these trucks, which keep the concrete in a mixed situation so that it can be used directly. And concrete testing. Concrete testing is in order to know if the concrete is of good strength, compressive strength for which it's used, we need to do certain tests, and this is one of the tests. This is called as the compressive strength test, and the procedure is to maintain the specimen in a moist condition and up to the time of compression testing, and then align the structure along the axis, and apply load in a consistent way at the rate of 20 to 50 psi per second, that is 150 to 350 pounds per second for a 3-inch diameter cylinder, 250 to 630 pounds per second for a 4-inch diameter, and then test when it fails. The time it fails gives you the compressive strength of the concrete. So there are certain standards according to which concrete has to be made. It has to take in certain amounts of load, and if it doesn't, which means the concrete is not of good quality, you got to remake it, and you cannot use it for construction purposes. So this particular test is actually used for knowing if the concrete which you made is of good quality and can be used. And this is my specialization. It's basically converting dirty water into drinkable water, and there's something called as a slow sand filtration process. It just uses gravel and bunch of stuff to make water clean, and yeah, the procedure is like pretty simple. So they're used in water purification. They're basically basins which are 1 to 2 meters deep, and they could be cylindrical or rectangular in cross section, and they're used for smaller plants for lesser flows. I mean, this cannot be used for big plants which have 5 to 10 million gallons per day capacity. This could be used at a smaller scale, and they have a very slow loading rate. What happens is the water is put onto gravel, rock, and the number of layers, and the water flows through them, and then they come out as clean water. This was the most primitive method of cleaning water initially, and since water is a huge, it's an elixir for life, and right now we nearly have 1.1 billion people in this world who don't have drinking water, and nearly 1.1 million people who die out of diseases because of unclean water. So water treatment is something which people need to think of, and it's surely got to have a future, because water is an elixir for life. And my subject of interest is in water treatment, and I do reading into more advanced methods of treating water. And this is one of the primitive ones. This would give you an idea of what water treatment can do. It can convert wastewater into clean drinkable water. And most of the water which we get in our drinking water system actually is wastewater which gets converted into clean water, then it's sent to a water treatment plant for further purification, and then sent into the distribution network. So water is got a tremendous future, and one should have a little interest in it. And then this process of filtration is and it's a non-pressurized system, so you do not require chemicals or electricity to operate. So slow sand filtration on a small scale is also pretty green. It's good on the environment. You don't spend too much electricity or too much of chemicals. You don't spend anything at all. It's just cleaning. It's a depressurized system. You just put in the water comes out. But this cannot be used for high levels of cleaning. The US Environmental Protection Agency expects the water to be of a certain level that cannot be used, that cannot be attained using this process, but it's good enough for developing countries where the quality of water is pretty bad. And yeah, I mean, there's the number of, and another way to induce the interest in civil engineering is to go to one of the construction sites, and there are lots of construction happening around the UDA campus, and one could have a look at them, or probably the campuses you people are in. You could have a look at it, and you can talk to engineers there, site engineers there, the kind of work they do. It calls for a lot of people to work for a lot of time for a proper structure to function. So basically your education gives you all the necessary aptitude to become an engineer. You got to work in a group. You cannot be selfish. You got to solve problems. Irrespective of what the problems may be, you might have a lot of variables coming in. You got to put your brain into it, do a lot of thinking, and then come up with a result. But at the end of the day, if you come up with the right results, it gives you a very high satisfaction. So civil engineering is something one should consider as a career option.
Go back to that thing and let them, encourage them to do the bridge.
Oh, okay.
And that's if they have questions.
Yeah. This one? Yeah. Yeah, the challenge is to build a bridge that spans 30 inches and holds the most weight. And all you need to use is 250 straws and sewing pins and some scotch tape. This requires a lot of imagination. You could and some conceptual knowledge. The straws have to be put in the right way, and you should know a little bit of physics of point sources, point forces acting, and how to solve a truss. And you would be surprised that straw can hold so much weight, and it's just because of the forces cancelling themselves, and at the end of the day, the entire structure stays in equilibrium. So this is one of the challenges which could be thought about. Yeah. How do I do that? You have any questions now? What's instructor?
What do you like about environmental engineering?
What do I like?
Yes.
Just that we've done enough damage to the world. It's time we start cleaning the mess we created, and it's high time we do that too. And water, I'm into water treatment, so water is a commodity which could lead to huge conflicts in the future, because water is what's needed. I mean, without water, life doesn't exist in the world. So environmental engineering is something one should think of, because it's got a huge future, because the environment has to be protected at any cost, and people have to do research in it. Any other questions?
You got your bachelor's.